If we left in 2026, how long would it take to leave the solar system? At first, that sounds like the kind of question that should have one clean answer. It feels as if we are asking for a number, a certain amount of years, maybe a certain spacecraft, maybe a certain speed. We imagine a straight path outward, a long journey away from the sun, and then, at some point, we pass a final border, and the answer is complete. But the moment we sit with the question for even a little while, something unexpected happens. The problem is not only how far we would have to travel. The problem is that we are not fully sure where the thing we are trying to leave actually ends. That is what makes this question so much more interesting than it first appears. When most people picture the solar system, they picture the sun at the center and the planets circling around it. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, maybe Pluto, depending on how they learned it. In that picture, the solar system feels like a kind of family portrait, a set of worlds gathered around one star. It feels organized. It feels understandable. And because it feels understandable, it also feels as if it should have a clear outer edge. But space is rarely that neat. The solar system is not a solid object. It does not have walls. It does not have a bright ring around it that says, "The sun's kingdom ends here." It is not like a country with a border crossing, or an island with a shoreline, or even a room with a door. It is a region of influence, and influence can fade in different ways. That changes everything. Because if you ask where the solar system ends, one person might think of the last planet. Another might think of Pluto. Another might think of the far icy bodies that drift in darkness well beyond the planets. Another might say the real edge is not marked by rocks at all, but by the reach of the solar wind, the stream of particles flowing outward from the sun. And someone else might say that none of those are the true end, because the sun's gravity reaches much farther still. So before we can answer how long it would take to leave the solar system, we have to face a stranger question. What exactly are we trying to leave? That sounds like a technical detail, but it is really the heart of the whole journey, because each possible answer creates a different story. If leaving the solar system means simply going past the planets, then the journey has one shape. If it means crossing into interstellar space, where the sun's wind no longer rules the local environment in the same way, then the journey becomes something else. And if it means going so far that the sun's gravity no longer keeps you meaningfully inside its long, fading domain, then the timescale stretches even farther. So the title opens up instead of narrowing down. It begins as one question and quietly becomes several questions at once. How far is far enough? What counts as outside? What kind of boundary would actually feel like the edge? And maybe the most human version of all. When would we truly feel that home was behind us? That last part matters more than it may seem. Because when people ask a question like this, they are usually not only asking for a scientific definition, they are also asking for a moment. A point in the journey when it would feel real. A point when we could honestly say that something built by human hands had gone beyond the place we call home. That is why the question has such power. It sounds like a travel question, but hidden inside it is a question about scale, meaning, and perspective. It asks us to measure not only distance, but belonging. It asks us to think about how far the sun's world really reaches, and how small our usual mental map of it might be. Because if the solar system is larger, softer at the edges, and stranger in structure than most of us imagine, then even the first step in answering the title requires a different kind of map. Not just a map of planets, but a map of layers, regions, and fading influence. And once we begin to see that map more clearly, the simple question starts to sharpen. If there is more than one possible edge, then which one are we really talking about when we say we want to leave the solar system? That depends on what we mean by the solar system in the first place. If we only mean the familiar picture most of us carry in our heads, then the answer seems easy. The sun sits in the middle. The planets circle around it. The rocky worlds stay closer in. The giant worlds spread farther out. Pluto, whether we think of it as a planet or not, drifts far beyond Neptune. In that version, the solar system feels like a set of named objects, a collection, a lineup, something that could, at least in theory, have a last member and then simply stop. But the real solar system is wider and softer than that. The sun does not only hold planets around it, it reaches outward in other ways too. Its gravity stretches far beyond the worlds we can list from memory. Its light pours outward in every direction. Its magnetic influence matters. Its solar wind, a constant stream of charged particles flowing away from the sun, pushes through space and shapes a vast bubble around our star. And beyond the planets, beyond Pluto, beyond the places most school diagrams bother to show, there are still icy bodies, scattered objects, and distant regions that remain part of the sun's long, fading neighborhood. So the question starts to shift. Maybe the solar system is not only the place where the planets are. Maybe it is also the place where the sun still matters strongly enough to shape the environment around it. That is where the edge becomes harder to pin down. In the simplest everyday sense, the answer is already huge. With modern-day spacecraft, leaving the solar system would take decades, not years. Imagine standing at the shore of an ocean. You can point to where the land ends and the water begins. The line may move with the tide, but it still feels like a line. Space is not like that. In space, boundaries often behave more like fading weather than like solid walls. One influence grows weaker. Another begins to matter more. A region changes character slowly, then more clearly, then suddenly enough that we give it a name. That means there is no single obvious edge waiting for us out there like a fence. There are several possible edges, and each one tells us something different. One possible edge is the last major planet. That feels natural because planets are the most visible and familiar parts of the solar system. If you pass Neptune, it is easy to feel that you are nearing the end of something important. But Neptune is not the end. Pluto is farther out, and beyond Pluto, there are still many frozen bodies orbiting the sun. Another possible edge is the Kuiper belt, a broad region filled with icy objects left over from the solar system's early history. This is already much farther out than the tidy textbook image most of us grew up with. It tells us that the sun's family is less like a row of planets and more like a wide, thinning field of matter. Then there is the heliosphere, the enormous bubble created by the solar wind. The sun is constantly sending particles outward, and these particles push against the material that exists in the space between stars. As long as the sun's outward flow is shaping the local environment, we are still, in an important sense, inside the sun's personal space. The outer boundary of that bubble is called the heliopause. Cross that, and the surroundings begin to feel more like interstellar space than like the inner environment dominated by our own star. That sounds like a powerful kind of border, and it is. But it still may not be the final answer. The sun's gravity keeps reaching outward long after the solar wind grows weak. gravity does not stop at the heliopause. It keeps holding distant objects in orbit far beyond the planets and far beyond that great bubble of solar wind. So if someone says the solar system should mean everything that still belongs to the sun gravitationally, then the true edge moves even farther away. And that is what makes the question so slippery. We can mean the solar system of planets. We can mean the solar system of icy outer bodies. We can mean the solar system as a bubble in space carved by the solar wind. Or we can mean the solar system as the full reach of the sun's gravity. Each meaning is reasonable. Each one gives us a different border, and each border gives us a different answer to the title of this video. So when we ask how long it would take to leave the solar system, we are not yet choosing a number. We are choosing a definition. We are deciding which kind of edge feels most real, most useful, or most meaningful. And once there are several possible edges in front of us, the next question becomes the one that matters most. Which of those edges actually deserves to count as leaving? That is where the question begins to split. Once we realize the solar system has more than one possible edge, the title stops behaving like a single journey. It becomes several journeys laid on top of each other. They all begin in the same place, with a departure from Earth and a path outward into deep space. But they do not all end at the same point. Each one chooses a different moment and says, "This is where leaving truly happens." That is why there are several valid answers to the question. If someone says leaving the solar system means going beyond the planets, that answer makes a kind of emotional sense. For most of human history, the planets were the solar system. They were the great visible worlds moving through the sky, the markers that gave structure to our picture of the sun's family. If a spacecraft passed Neptune and kept going, many people would feel that it had crossed the far side of the known map. It would feel as though it had gone beyond the main body of the sun's world. But even that is only one version of the story. Beyond Neptune and beyond Pluto, there is still a wide region filled with smaller frozen bodies. The solar system does not stop where the last major planet stops. It thins out. It becomes less familiar. The named worlds give way to scattered objects and distant remnants from the solar system's early formation. So if we decide that leaving the solar system means moving beyond the broad field of icy outer bodies, then the finish line moves farther away, and farther still. Because another answer cares less about objects and more about environment. The sun is not only a source of gravity and light, it is also constantly sending out solar wind, a stream of charged particles rushing outward in all directions. That flow pushes into the material between the stars and creates an enormous bubble around the sun. Inside that bubble, the sun still shapes the local conditions in a direct way. Outside it, the surrounding space belongs more to the wider galaxy than to our star. That outer boundary, the heliopause, has a special power in this question. It feels like a real crossing, a change in conditions, a place where one space environment gives way to another. If a spacecraft reaches that line, many people would say it has finally entered interstellar space, and that feels like a very strong candidate for what it means to leave the solar system. But even here, the matter is not fully settled, because the sun's gravity does not end at the heliopause. Gravity keeps reaching outward, holding distant objects in very long orbits. In that sense, the sun's influence extends much farther than the bubble made by solar wind. So if we decide that the solar system includes everything still bound to the sun by gravity, then crossing the heliopause is not the end. It is only one threshold among others. And that brings us to the deepest version of the question. What if leaving the solar system means escaping the sun entirely? Not just leaving the region where the planets are, not just moving beyond the icy outer bodies, not just crossing into interstellar space, but traveling far enough that the sun no longer holds you as part of its long gravitational domain. That answer is the most demanding of all. It stretches the journey into something even larger than most people mean when they first hear the title. But it is still a reasonable answer. In fact, it may be the most complete answer if what we care about is true departure from the sun system in the deepest physical sense. So now the title has opened into 4 broad possibilities: passing the planets, moving beyond the Kuiper belt and the outer icy population, crossing the heliopause into interstellar space, or escaping the sun's grip altogether. Each one is valid. Each one gives the viewer a different sense of what counts as outside. And each one produces a different timescale, a different emotional weight, and a different idea of what the journey really means. That is why this video cannot begin by rushing to a number. The first task is to understand what kind of ending we are even searching for. A clean answer will only make sense after we understand the different doors that the question has quietly opened. Because one title now contains several endings, and before we can choose the one that matters most, we need to feel the size of the space those endings are sitting inside. How large is the solar system, really? Once we stop thinking of it as a neat classroom diagram and begin thinking of it as a real place. That is the part our minds tend to miss. When most of us picture the solar system, we see the sun in the middle and the planets arranged around it like pieces placed neatly on a page. Even when the picture is meant to show distance, it usually cannot do it honestly. If it did, the planets would be so tiny and so far apart that the image would stop being useful. The page would be mostly blank. The worlds would feel less like neighbors and more like small islands in a black ocean. And that is much closer to the truth. The solar system feels manageable when it is turned into a diagram. It feels much less manageable when it is turned back into real space. The planets are familiar names, but the space between them is where the true scale begins to reveal itself. Those gaps are so large that the planets do not form a tight family portrait at all. They form a scattered set of markers spread across distances that are hard to carry in the mind. Earth already feels far from the sun in everyday thought. The sun lights our sky, warms our planet, and feels central to everything. Yet it is around 150 million kilometers away. That number is so large that it stops behaving like an image and starts behaving like a blur. And Earth is still close in. It is part of the inner solar system, living near the warm center of the sun's neighborhood. Move outward to Mars, and the scale grows. Move farther to Jupiter, and it grows again. By the time we reach Saturn, then Uranus, then Neptune, the spaces between worlds are no longer just impressive. They are defining. The journey is not difficult because the planets block the way or because the route is crowded. The journey is difficult because there is so much almost nothing in between. That emptiness matters. It matters because emptiness takes time to cross. It matters because a spacecraft can move for years and still seem to have barely changed its place in the wider structure. It matters because our instincts are built for landscapes, roads, and horizons, not for distances where even the major landmarks are separated by billions of kilometers. And when we move beyond the planets, that feeling only deepens. A person might imagine that once you pass Neptune, you are almost done. After all, Neptune is often treated like the last major stop. But the solar system does not reward that assumption. Beyond Neptune, space keeps opening. Pluto lies far beyond. The Kuiper belt spreads outward in a broad region of ice and darkness. And farther still, the Sun's influence continues in ways that cannot be seen from a simple line of planets on a chart. So the solar system is not only large because it contains many things. It is large because the things it contains are so widely separated that the structure itself is mostly gap. That is one of the strangest truths about our home system. Its story is told by named objects, but its scale is ruled by the empty places between them. The Sun is huge. The planets are large worlds. Some of them are giants beyond anything on Earth. But in the larger map, even those giants begin to look like points. A planet can be enormous in itself and still function mainly as a small signpost in a much larger emptiness. That is why space travel changes character the farther out we think. At first, we imagine destinations. Soon, we start to realize that the real challenge is the long silence between destinations, and that silence keeps growing. The more honestly we imagine the solar system, the less it resembles a crowded system of worlds, and the more it resembles a vast field with a few bright markers scattered through it. The planets remain important, but they no longer feel packed together. They begin to feel isolated. The Sun remains the center, but the region around it begins to seem almost impossibly wide. That change in perspective is important, because once we feel the scale more clearly, another question naturally becomes harder to avoid. If the solar system is this large, if even its familiar inner structure is spread across such enormous distances, then what do our machines really mean inside it? What counts as fast in a place like this? A rocket leaving Earth can feel powerful. A spacecraft can seem astonishingly quick by human standards. But the solar system does not measure speed the way we do on Earth. It measures speed against emptiness. And that means the next step in this journey is not only to ask how far we must go, but to ask how quickly we are actually capable of moving through a place this large. That is where the word fast begins to change its meaning. On Earth, speed feels simple. A jet is fast. A bullet is fast. A rocket rising through the sky feels unbelievably fast. Even in orbit, the numbers are so large that they sound almost unreal. A spacecraft leaving Earth is moving at a speed that no human body could ever directly experience in ordinary life. It crosses countries, oceans, and continents in moments. It leaves the atmosphere behind. It escapes the grip of our planet. By any normal standard, it is doing something astonishing. And yet, in the solar system, that same kind of speed quickly starts to feel small. A real departure in 2026 would not begin with some magical new engine that suddenly makes the outer solar system feel close. It would most likely begin in a way we already understand. A rocket would lift a spacecraft away from Earth. The craft would gain enough speed to escape Earth's gravity, then use careful planning, momentum, and possibly gravity assists from planets to build an outward path. It might be elegant, it might be efficient, it might be one of the best things our engineering can do. But it would still be moving inside a system so large that even our finest speeds struggle to make the map feel smaller. That is the difference between leaving Earth and crossing the solar system. To leave Earth, a spacecraft needs to reach escape velocity, which means moving fast enough to break free from Earth's pull. That is a major achievement. It is one of the great acts of human engineering. But escaping Earth only solves the first layer of the problem. Earth is one world. The solar system is an entire star system. Rising out of one gravity well is dramatic, but it does not carry us very far through the much larger emptiness beyond. Even the fastest spacecraft humans have built do not race across the solar system the way our instincts want them to. They move with great power, but across distances so extreme that years can pass before a major milestone is reached. A mission can be considered incredibly successful and still spend a long time crossing only the early portions of the sun's domain. That is why space documentaries often create a strange feeling. You hear a number that sounds enormous, then hear a travel time that sounds long, and both are true at once. The spacecraft is moving very fast. The destination is just much farther than our minds are built to handle. A useful way to think about this is to separate two ideas that often get mixed together. The first is raw speed. How fast is the spacecraft moving? The second is meaningful progress. How much of the solar system is actually being crossed? Those are not the same thing. A spacecraft can be moving at tens of thousands of kilometers per hour and still be making progress that feels slow once the route stretches outward past the familiar planets. That is because the outer solar system does not punish us with obstacles. It punishes us with scale. The challenge is not weaving through crowded space. The challenge is staying in motion long enough for motion to matter. And that is what a 2026 mission would inherit. It would inherit all of our current strengths: powerful launch systems, deep knowledge of orbital mechanics, decades of mission planning, the ability to use planetary flybys to gain speed, better materials, better computers, better tracking. A 2026 departure would not be primitive by the standards of human history, but by the standards of the solar system, it would still be young. That may be the most humbling part of all. Our technology is advanced enough to leave Earth, advanced enough to reach other planets, advanced enough to send probes to the edge of the sun's visible neighborhood. But it is not advanced enough to make those distances feel casual. We are capable of starting the journey. We are not yet capable of making the journey feel small. So when we ask how fast a real 2026 departure would be, the honest answer is this: fast enough to escape our world, fast enough to cross great distances by human standards, and still slow enough that the outer solar system remains a place measured in long stretches of time. That means the title of this video cannot be answered by speed alone. Speed only becomes meaningful once we place it into the route itself. Because if this is the kind of motion we can actually achieve, then the next question becomes more concrete. What does the first part of the journey really look like once we leave Earth behind? That is the strange part of space travel. It begins with something so dramatic that it can hide how little of the journey has actually been completed. A launch from Earth feels enormous because for us, it is enormous. A rocket rises through the atmosphere on fire. It breaks free from the ground, crosses the sky, and enters a realm human beings were never built to survive in naturally. To leave Earth is one of the hardest things our species has ever learned how to do. It takes precision, power, timing, fuel, and years of planning. From the point of view of human life, escaping Earth is a triumph. From the point of view of the solar system, it is an opening movement. That shift in perspective is important because it changes how we feel the title of this video. If we say we left in 2026, part of the mind wants to treat that as the main event. It sounds as though the difficult part has already happened. We imagine the spacecraft is now truly on its way, perhaps already deep into the cosmos. But once Earth begins to shrink behind us, the larger truth comes into view. We have only stepped out of one room in an enormous house. Earth is home, and home feels large when we are standing inside it. Its gravity rules our bodies. Its atmosphere surrounds us. Its surface gives us weather, oceans, continents, and the whole theatre of everyday life. So leaving Earth feels like leaving a complete world, because it is. But the solar system is made of many scales laid inside one another. There is Earth's scale, then the scale of the moon's orbit, then the wider scale of the planets, then the still wider regions beyond them. Escaping one layer does not mean we have escaped the whole structure. Even reaching the moon, which seems far away in human thought, barely begins to answer the larger question. The moon is close enough that astronauts reached it within days. That is extraordinary by the standards of human travel. Yet in solar system terms, it is still our front yard. It tells us something important about our ability to move through space, but almost nothing about our ability to leave the sun's domain. The same is true in a larger way for Mars. Mars feels like deep space in our imagination. It is another planet, a dusty world with its own seasons, its own sky, its own long place in human dreaming. To send people there would be one of the greatest milestones in history. And still, Mars sits in the inner part of the solar system. Reaching Mars would mean we had gone far beyond Earth in human terms, but only a small distance in the context of the entire outward journey. That is one of the most humbling truths in all of space exploration. A destination can be historic, difficult, and astonishing, while still being close to the beginning. The reason is simple. The solar system is not measured only by the distance from Earth to the next destination. It is measured by how far the sun's influence reaches, and that reach is vast. Moving from Earth outward does not carry us quickly toward a clean finish line. It carries us into a widening series of regions, each one larger than the last, each one making the early milestones feel smaller in hindsight. So a spacecraft leaving Earth today would certainly accomplish something real. It would escape our planet. It would begin a true outward journey. But if the title asks when we leave the solar system, then leaving Earth is best understood as the point where the question becomes active, not the point where it is close to being answered. That makes space travel feel different. Smaller, in one sense. More honest, too. It reminds us that our first burst of motion, as powerful as it is, does not carry us very far across the larger map. The launch matters because it begins the journey, but the scale of the journey quickly makes the launch look like the first small push away from shore. And once we begin to accept that, the next change in perspective follows naturally. If Earth is only the first step, then what happens as we move outward through the familiar solar system itself? How do the planets change from destinations into mile markers? And at what point does the path ahead start to feel less like travel between worlds and more like a long crossing through emptiness? That is where the planets start to change in meaning. At first, they feel like destinations. They are the great named worlds of the solar system, the places that give space its structure in the human mind. Mars feels far. Jupiter feels enormous. Saturn feels distant and grand. Uranus and Neptune seem so remote that it is easy to imagine they must sit near the border of everything the sun controls. But they do not. That is one of the most important answers in this whole journey. Even the outer planets are still deep inside the solar system. Reaching them would be extraordinary by human standards, but it would not mean we were close to leaving the sun's domain. That is the part our instincts tend to get wrong. We are used to maps where the major landmarks help define the size of the whole place. If you know where the last major city is, you feel as if you are starting to understand the country. If you know where the shoreline is, you understand where the land ends. So the mind wants to treat Neptune the same way. It wants to believe that once you reach the last major planet, the edge must be near. In reality, Neptune is more like a late checkpoint than a finish line. It is very far away, of course. So far, that sunlight there is weak and cold compared with what we know on Earth. So far, that Neptune takes about 165 Earth years to go around the Sun once. That single fact alone tells us something important. A world can be so distant that 1 year there lasts longer than a human lifetime. And still that world can remain clearly inside the Sun system. That should immediately change the scale of the title question. Because if Neptune is still inside, then leaving the solar system must mean something much larger than simply reaching the farthest major planet. The same is true for all the outer planets. Jupiter is a giant, but it is still part of the inner story compared with what lies ahead. Saturn feels remote, but it is still orbiting well within the Sun's broad reach. Uranus and Neptune feel like the dark frontier, yet even they belong to a region where the solar system is still easy to recognize as the Sun's organized family of worlds. So the planets matter, but they matter in a different way than we may first think. They show progress. They do not show completion. That distinction is worth holding on to, because it helps the whole question become more honest. A spacecraft passing Mars would be making progress. A spacecraft passing Jupiter would be making major progress. A spacecraft passing Saturn, Uranus, and Neptune would be moving into truly remote territory. But none of those moments, by themselves, would answer the title of this video. That is a real payoff in its own right. It means the phrase outer solar system is less final than it sounds. It is easy to hear that phrase and imagine a boundary, but often it only means the outer planetary region, which is still a long way from the deeper edges we are trying to understand. In other words, the planets are not the border. They are the last clearly named landmarks before the map becomes stranger. That makes them more interesting, not less. They become the points where our confidence starts to fade. Up to Neptune, the solar system still looks somewhat familiar. There are orbits, names, major worlds, places we can point to. Beyond Neptune, that tidy feeling begins to thin out. The named planets fall behind. The route becomes less about moving from world to world and more about entering a wider and quieter region where the Sun still matters, but where the structure is no longer as easy to picture. That is the real shift happening here. The planets are teaching us that our usual mental map is too small. They are showing us that the solar system is not defined by its biggest worlds alone. It continues past them, into darker and looser regions that most people almost never imagine when they ask where the solar system ends. So by the time a spacecraft has crossed the orbit of Neptune, something important has happened. It has not left the solar system, but it has left behind the part of the solar system that feels most familiar to us. It has moved beyond the last major planet and into a region where the question becomes more mysterious again. And that naturally leads us to the next step. If the planets are only checkpoints, then what exactly waits beyond them in the dark? By the time a spacecraft passes Neptune, most people would probably feel that it had gone almost all the way. That reaction makes sense. Neptune is the last major planet. It sits so far from the Sun that even sunlight feels weak there. and a single orbit takes about 165 Earth years. Reaching that distance already sounds like the kind of thing that should answer the title. If leaving the solar system were only about passing the known planets, then the journey would feel close to complete. But that is exactly where the real scale begins to show itself. Because Neptune is not the edge. It is better understood as the last major landmark before the solar system starts fading into larger and stranger outer regions. That means a spacecraft reaching Neptune has done something extraordinary, but it still has much farther to go before most people would say it has truly left the Sun's world. And that is where the numbers begin to matter more. With modern-day spacecraft speeds, reaching Neptune is already a journey measured in many years. It is not a quick crossing. It is not even close to one human season of life in ordinary terms. It is a mission, a long one. The kind that reminds us that even the planetary part of the solar system is enormous. But beyond Neptune, the map does not end, it loosens. The first major region beyond the last planet is the Kuiper belt, a wide zone filled with icy bodies and frozen remnants from the solar system's early history. Pluto lives there. So do many other distant objects. This means that once the planets are behind you, you are still moving through a region that clearly belongs to the Sun. You are still surrounded by objects in orbit around it. The solar system has become thinner and darker, but it has not been left behind. That gives us a more useful way to feel the question. Earth to Mars is still the early journey. Earth to Jupiter feels serious. Earth to Saturn feels immense. Earth to Neptune already feels extreme. But Earth to the Kuiper belt, and then through it, begins to feel like the outer system in a deeper sense. So the answer is getting longer as the definition gets more honest. And there is another outer layer that matters even more than the icy objects. The Sun is constantly sending out solar wind, a stream of charged particles moving outward in all directions. Over time, that flow creates a giant bubble around the Sun called the heliosphere. As long as a spacecraft is moving inside that bubble, it is still traveling through a region where the Sun shapes the local environment in a direct way. That matters because it gives us one of the first truly satisfying working answers to the title. If you mean leaving the solar system in the everyday sense of leaving the Sun's active local domain, then the heliosphere matters more than Neptune does. And the boundary of that bubble, called the heliopause, lies far beyond the planets, far beyond Neptune, far beyond the last major named world. Reaching it with modern-day technology is a journey measured in decades. That is the clearest payoff we have had so far. Even the simplest strong version of the answer is already this. With modern-day spacecraft, leaving the solar system is not a matter of years. It is a matter of decades. And even that is only one version. Because after the heliopause, the Sun's gravity still reaches farther. Its direct environmental bubble may have ended, but its gravitational family may continue much deeper into space. That means the title question still has more than one possible finish line. But at least now the scale begins to feel real. The outer planets are not close to the edge. The Kuiper belt is not the final stop. Even the first major exit sits much farther out than most people imagine when they first hear the question. So the solar system is no longer a tidy row of planets in our minds. It has become a layered outward journey. First the inner planets, then the giant worlds, then Neptune, then the dark, icy outer region. Then, much farther still, the boundary where the Sun's bubble gives way to interstellar space. That progression is important, because it finally lets us feel what kind of answer this video is moving toward. We are no longer asking whether the edge is vaguely far away. We are starting to see that even the first meaningful edge is a destination that modern human technology reaches only after a very long outward crossing. And once that becomes clear, one boundary begins to stand above the others. Because among all these outer layers, the heliopause is the first one that feels less like a fading region and more like a true threshold. That is why the heliopause begins to matter so much. By this point, the journey has already carried us beyond the last major planet, beyond the simple classroom picture of the solar system, and into a much larger idea of what the sun's domain really is. The planets are behind us. The outer icy regions have widened the map. And still, the question remains, when would it actually feel fair to say that we had gone outside? The heliopause is the first answer that feels strong enough to satisfy that question. It matters because it marks the outer boundary of the heliosphere, the giant bubble created by the solar wind. The sun is constantly sending out a stream of charged particles in all directions. That flow moves outward across the solar system and shapes the local space environment far beyond the planets. As long as the spacecraft is moving inside that bubble, it is still traveling through a region where the sun is actively pushing its presence outward. The heliopause is where that changes. It is the place where the pressure of the solar wind is finally matched and overcome by the material that already exists in the space between stars. Beyond that boundary, the sun is still visible. Its gravity still matters in larger ways. But the local environment is no longer being dominated in the same direct way by the outward breath of our star. A spacecraft crossing that line enters a region that feels less like the sun's personal bubble and more like the wider galaxy. That is why this boundary feels different from Neptune, different from Pluto, and different even from the Kuiper belt. Those are objects and regions inside the system. The heliopause feels more like a true crossing. It is not simply another faraway place. It is a change in surroundings, a change in conditions, a change in what kind of space you are moving through. And that gives us the first concrete, satisfying version of the title's answer. If by leaving the solar system we mean leaving the sun's active local bubble, then with modern-day technology, the journey is measured in decades. That is already a real answer. It is not vague. It is not symbolic. It is not just philosophical. It means that even the first strong version of outside sits so far away that a spacecraft launched in modern times would spend a large portion of a human lifetime reaching it. That alone changes the emotional weight of the question. At the start, leaving the solar system may sound like an extreme version of traveling to another planet. Something longer, certainly, but still understandable in the same general way. The heliopause shows that this instinct is too small. The first true threshold is not a short extension of planetary travel. It belongs to a different category of journey altogether. It is deep time travel by human standards, the kind that forces patience onto the mission whether we want it or not. And yet the heliopause is not infinitely far away. That matters too. It is distant enough to humble us, but close enough that it belongs to the world of real spacecraft, real missions, and real engineering. It is not a fantasy border waiting in some unreachable future. It is a physical threshold that exists right now, surrounding our star, marking the place where the sun's bubble gives way to interstellar space. So the heliopause does something important for the story. It turns the title from a loose thought experiment into a sharper journey with a destination that feels real. It gives the outward motion a border that is meaningful in both scientific and emotional terms. If a spacecraft crossed it, most people would feel that something genuine had happened. Human technology would have moved beyond the sun's local envelope and into the wider medium between stars. That is the first moment in this video where the phrase "leave the solar system" begins to feel like it can actually land. Not completely, perhaps. There are still deeper definitions ahead. The sun's gravity stretches farther. Its longer reach does not end here. But the heliopause gives us the first answer that feels like a true threshold, rather than just another distant checkpoint. And that is why it stands out. Among all the possible edges, this is the first one that feels like outside in a way the human mind can immediately grasp. Which raises a powerful next question. If this boundary is so meaningful, has anything we have ever built actually made it there? That question becomes much harder to ignore once we remember that this is no longer only a thought experiment. Humanity has already sent something into that outward darkness. Voyager 1 was launched in 1977, long before the modern digital world took shape, long before most of the technology we now take for granted even existed. It began as a planetary mission, part of a remarkable moment in space exploration, when the outer planets could be visited through a rare alignment. But Voyager did not stop being important when its early mission was complete. It kept going. It kept moving outward year after year, decade after decade, becoming something larger than the mission it first set out to be. That is what makes Voyager so powerful in this story. It gives the title a real object to follow. We do not have to imagine from scratch what it means to head for the edge of the sun's local domain. We have already done it, at least with a machine. Voyager turned outward escape from an abstract idea into a lived engineering fact. It proved that a human-made object could travel far enough and long enough to approach one of the most meaningful boundaries in the entire solar system. And yet the lesson it gives us is not comforting. Voyager proves the journey is possible. It also proves how slow that journey really is. For years, Voyager moved through the outer planetary region. Then it kept going long after the planets had fallen behind. It crossed into the far reaches of the sun's extended neighborhood and continued outward until, after decades of travel, it finally crossed the heliopause. That crossing was historic. It meant that a spacecraft built by human hands had entered interstellar space in the most immediate local sense. It had moved beyond the sun's solar wind bubble into the wider medium between the stars. That is an astonishing achievement. It is also a humbling one, because it took about 35 years. That number matters. It is one of the first hard emotional anchors in the whole story. Leaving the solar system, in the strongest everyday sense we have discussed so far, is not a journey of months. It is not even a journey of a few years. Our best real example shows a journey measured in decades. A child could be born on the day of launch, grow into full adulthood, and still be waiting for the crossing. That changes the feeling of the title. It makes the question less cinematic and more patient, less like a dramatic sprint into the unknown, and more like a long, quiet act of endurance. Voyager did not blast out of the solar system in one bold move. It drifted there through time. It crossed that threshold because it never stopped going. And that may be the deepest lesson Voyager offers. In the solar system, persistence becomes a kind of speed. The spacecraft itself is not fast in the way our imaginations often want deep space travel to be. It is fast by human standards, of course. Anything traveling through the solar system at that pace is extraordinary by everyday measure. But when placed against the sun's outward reach, even Voyager begins to feel less like a dart and more like a patient traveler crossing an enormous plain. That is why Voyager is so valuable as a benchmark. It tells us that the heliopause is not some imaginary line too distant to matter. It tells us the first true threshold is real, reachable, and already crossed. But it also tells us that the cost of reaching it, with the kind of technology we have actually used, is time, a great deal of time. So when people ask how long it would take to leave the solar system, Voyager offers the first answer that feels grounded enough to trust. If you mean leaving the sun's local bubble, then the answer is on the order of decades. Not because that sounds dramatic, but because one of our own machines has already lived that answer for us. And still, Voyager leaves another question hanging in the silence behind it. Voyager was launched in 1977. It belongs to an earlier age of engineering, an earlier age of computing, an earlier age of mission design. It is one of the greatest spacecraft ever built, but it is also old by the standards of modern technology, which means its lesson cuts in two directions at once. It shows us what outward escape really costs, and it makes us wonder how much better we could do now. If Voyager is our best real guide to the journey, then what would a modern-day departure inherit from everything we have learned since? That question invites a very natural hope. Voyager was launched in 1977. It came from an earlier era of engineering, an earlier era of computers, an earlier era of materials, planning, and spaceflight experience. So it is tempting to assume that a modern-day departure would leave it far behind. We know more now. We build more precise machines. We guide spacecraft with better software. We understand planetary flybys, trajectories, and mission design much more deeply than we did when Voyager first left Earth. All of that is true. A modern-day mission would almost certainly be smarter in many ways. It could be designed more efficiently from the beginning. It could take advantage of decades of lessons learned from deep space missions, outer planet missions, and improvements in propulsion, power systems, and navigation. It could be shaped around the exact goal of moving outward as effectively as possible, instead of beginning as one kind of mission and later becoming another, the way Voyager did. So yes, a modern-day mission could do better, just not better enough to make the solar system feel small. That is the key point. We often imagine progress as something that changes the whole nature of the problem. On Earth, that can happen. A faster car changes a journey. A faster airplane can make a distant country feel near. A better computer can shrink hours of work into seconds. We get used to progress behaving like that. It takes something that once felt difficult and turns it into something almost casual. The solar system resists that kind of improvement. A better spacecraft helps. A better launch helps. A more efficient trajectory helps. But none of those improvements erase the size of the map itself. They do not take a journey measured in decades and magically reduce it to something that feels ordinary. The distances are simply too large. Progress can shorten the crossing, but it cannot change what kind of crossing it is. That is why the honest answer here feels slightly frustrating. A modern-day departure would likely outperform Voyager in some important ways. It could be planned more directly for outward speed. It could avoid some of the limitations of older systems. It might cut meaningful time from the journey, especially if it were built with the single purpose of reaching the outer thresholds as efficiently as possible. But the improvement would still live inside the same larger truth. We are trying to cross an enormous region around a star, and our technology, though remarkable, is still early compared with that scale. So the answer is yes, but only partly. Yes, we could do better. No, we could not do so much better that the heliopause suddenly becomes close. That matters because it keeps the story honest. It prevents us from turning modern technology into a kind of magic wand. We are more capable than we were in Voyager's day, but we are not living in the kind of future where the outer solar system has become easy. We are still living in the era where even a well-designed outward mission must accept patience as part of the design. In that sense, Voyager remains relevant precisely because progress has not erased its lesson. It still teaches us the scale of the problem. It still teaches us that endurance matters. It still teaches us that moving outward through the sun's domain is a long act, even when done well. That can sound disappointing at first, but it also gives the question more shape. We are no longer trapped between two extremes, between fantasy and ignorance. We do not have to pretend that nothing has improved, and we do not have to pretend that modern engineering solves everything. We can hold both truths at once. A modern-day mission could likely reach the first meaningful threshold faster than Voyager did, but it would still be a mission of many years, and very likely decades, depending on the exact goal. That last part begins to matter more now than it did before. Because once we accept that modern progress helps without fully solving the problem, the next question becomes more precise. How much of the answer depends on which edge we choose? If we only mean passing the planets, that gives us one timescale. If we mean the heliopause, that gives us another. If we mean something larger still, the answer stretches farther again. So the story is ready for a clearer comparison. If a modern-day spacecraft left Earth and headed outward, how different would the answer become depending on where we decide the solar system truly ends? That is where the title finally begins to show its full shape. Up to this point, the journey has been opening outward step by step. We have moved from Earth to the planets, from the planets to the outer regions, and from those outer regions to the heliopause, the first boundary that truly feels like a crossing. We have also seen that modern technology can improve the journey, but not enough to make the solar system feel small. And now, with that map in view, the question becomes clearer. How long would it take to leave the solar system? The answer depends on what we mean by leave. And once we say that plainly, the title stops looking like one answer waiting to be discovered. It starts looking more like a staircase where each step carries us to a different kind of edge and a different kind of timescale. If we mean leaving the main planetary region behind, then the answer is already large, but still within the scale of serious space missions. A spacecraft can reach the outer planets in years, not months. And those years are long enough to remind us that even the familiar solar system is enormous. By the time we reach Neptune, we have already crossed a distance that would have seemed almost impossible in earlier ages of human thought. But reaching Neptune does not feel like leaving the solar system in the deeper sense. It feels more like reaching the last major landmark. If we push farther and include the Kuiper belt, the answer stretches again. Now the journey is no longer about passing the last named planet. It becomes a journey through a broad outer region of icy objects that still clearly belong to the Sun. This takes us beyond the classroom version of the solar system and into a larger, colder, quieter map. The answer is still measured in long mission times, but the feeling has changed. We are no longer just visiting the planets. We are moving into the solar system's fading outskirts. And then comes the heliopause. This is where the answer becomes much more satisfying to ordinary intuition. If what people really mean is, when do we leave the sun's local bubble and enter interstellar space, then the answer becomes more serious and more emotionally powerful. With modern-day technology, this is a journey measured in decades. That is the first answer that strongly matches the feeling many people have when they ask the title question. It is not just passing faraway worlds. It is crossing a genuine threshold into the wider medium between stars. That answer is important because it feels complete enough for many viewers. But it is still not the largest answer. Because if we mean leaving the sun's influence in the deepest gravitational sense, then the timescale stretches farther still. The sun's solar wind may end at the heliopause, but its gravity continues much farther out. There may be distant reservoirs of objects, like the Oort cloud, still loosely bound to our star across unimaginable distances. In that sense, leaving the solar system fully is no longer just a matter of reaching interstellar space. It becomes a much longer departure from the sun's full gravitational family. And that answer does not merely add a few more years. It changes the scale of the whole question. Now the title is no longer asking about a very long mission. It is asking about a journey so extended that even the heliopause begins to look like an early threshold rather than a final one. The first strong answer was decades. This deeper answer reaches vastly farther. So the staircase becomes visible. Leaving the planets gives one answer. Leaving the Kuiper belt gives a larger one. Crossing the heliopause gives the first deeply satisfying one. Escaping the sun's full gravitational reach gives the largest one of all. That is the hidden structure inside the title. At first, the question sounds as though it should produce one number, but once we look closely, it produces a range of answers, each one more demanding than the last. And each answer is honest. Each one simply belongs to a different meaning of the word leave. That matters because it lets us stop forcing the question into a shape that does not fit it. The solar system is layered, so the answer is layered too. The title is simple on the surface, but beneath it sits a stack of increasingly powerful meanings. The farther outward we go, the more the answer changes from a mission timeline into a statement about how vast the sun's domain really is. And yet, even with all those answers in front of us, one more question remains. Which one actually feels like the answer people are hoping for when they click on a title like this? Because the most technical answer is not always the one that lands most strongly in the human mind. That is where the question becomes more human. Up to now, we have been moving through definitions, distances, and boundaries. We have seen that there is more than one way to answer the question. We have seen that the planets are not the edge, that the heliopause gives us the first strong threshold, and that the sun's gravity may carry the deeper answer much farther still. All of that matters. But when most people ask a question like this, they are usually reaching for something a little different from a technical definition. They are trying to picture the moment when it would really feel as though we had gone beyond home. That feeling matters because home is not only a location. Home is also a sense of belonging. It is the place where things still feel familiar, where the map still makes intuitive sense, where the central star still feels like the organizing heart of everything around us. So the best answer to the distance and time is not only about physics. It is also about when the journey crosses a line in the human imagination. That is why the outer planets do not quite satisfy the question, even though they are so far away. Reaching Neptune is extraordinary. It would mean crossing a distance almost too large to carry in the mind. But Neptune is still part of the familiar order. It is still one of the Sun's named worlds. It still belongs to the recognizable architecture of the solar system we grew up learning about. It feels remote, but it does not feel outside. The same is true, in a quieter way, for the Kuiper belt. It is farther out, dimmer, stranger, and much less present in ordinary thought. Yet it still feels like the fading edge of a place we know. The Sun is still clearly the center. The objects there still belong to its family. We may have gone beyond the planets, but we have not fully left the feeling of the solar system behind. That is part of why the heliopause has such power. Scientifically, it matters because it marks the outer edge of the Sun's solar wind bubble. But emotionally, it matters because it feels like the first place where the environment itself changes in a way we can grasp. A spacecraft crossing that boundary is no longer just farther from the Sun than before. It has entered a different kind of surrounding space. The Sun is still there, still bright, still gravitationally important in the larger picture, but its outward breath no longer shapes the local environment the same way. For many people, that is the moment when home begins to feel truly behind us. Not invisible, not gone, but behind us. That distinction is subtle, and it is important. The best answer to is not necessarily the most complete one in a strict scientific sense. If we insist on total gravitational escape from the Sun, the answer becomes larger and deeper. But that answer can also feel emotionally distant. It may be the most exact version of leaving, yet it is not always the version that lands most powerfully in the imagination. The heliopause often lands more strongly because it matches a very human need inside the question. People want a threshold they can feel, a real border, or something close to one. A moment when the story changes. A moment when the spacecraft is no longer just traveling through the outskirts of home, but has stepped into the wider dark between stars. That is why the best answer depends partly on perspective. A scientist may care about which definition is most precise. An engineer may care about which boundary is most measurable. But a viewer listening to this late at night may care about something else entirely. They may care about the moment when the journey stops feeling like a very long trip through the solar system and starts feeling like departure. That is not a lesser question. It is the human version of the question. And once we admit that, the question changes again. It is no longer only asking for a number or a boundary. It is asking about experience. It is asking when distance becomes separation, when the Sun becomes less like the center of our world and more like one star behind us among many stars ahead. That is a different kind of answer, and in some ways a deeper one, because it means the edge of the solar system is not only something out there in space. It is also something that happens inside the mind. It is the point where the journey becomes large enough, strange enough, and quiet enough that the old map no longer feels like home in the same way. And once the question becomes that personal, another one rises naturally from it. If that threshold matters partly because of how it feels, then what would the journey itself feel like over time, year after year, as home slowly thinned out behind us? That feeling begins long before any final boundary is crossed. A journey outward through the solar system would not feel like stepping through a door. It would feel more like watching something familiar grow thinner and quieter year after year. Home would not vanish in a single dramatic moment. It would remain present for a long time, but in a weaker and weaker way, until what once felt central began to feel distant, and what once felt near began to feel like memory. That is one of the strangest parts of moving through space at this scale. Distance is not only something measured by instruments. It changes the emotional shape of the journey. It changes what feels close. It changes what feels active. It changes what the sun, the planets, and even Earth seem to mean. At first, the inner solar system would still feel like the main stage. Earth would be the place of departure. Mars would still seem like a nearby neighbor in the larger map. Jupiter and Saturn would feel like the giant outer worlds waiting in the distance. The sun would still dominate everything, bright and powerful, the obvious center of the journey. But as the spacecraft kept going, that picture would begin to loosen. The planets would not disappear all at once. They would simply stop mattering in the same way. One by one, they would become places left behind, rather than places still ahead. Their orbits would remain part of the structure of the solar system, but emotionally, they would begin to feel like old landmarks on a road already traveled. The route would stop feeling like movement from one world to another and start feeling like motion through a widening silence. That silence is important. On Earth, even long travel usually comes with change all around us. Roads pass through towns, flights cross clouds and coastlines, ships move through weather and shifting horizons. There is always some sign that the world is changing around us. Deep space offers much less of that. A craft moving steadily outward would spend long stretches of time with no dramatic scenery at all. The major changes would be changes of scale, changes of distance, changes in what no longer felt near. That would make the journey feel almost dreamlike. The sun would still be there, always behind and ahead in the same sense, still the anchor of the whole system. But it would no longer feel the way it feels from Earth. Here, sunlight defines the day, shapes weather, warm skin, drives life. Farther out, the sun would remain the center of the system, while feeling less like a living presence and more like a bright fact in the distance. It would still matter completely, but it would begin to matter in a quieter way. The same would happen to Earth. Earth would not become meaningless. In some ways, it would become more meaningful. It would be the point from which the entire journey was measured. But that meaning would become more inward than outward. Earth would stop being part of the active surroundings and become the source of memory, the place all comparisons flowed back toward. A person imagining that outward journey would likely keep thinking in Earth terms for a long time. Earth years, Earth distance, Earth time, Earth life. And then, slowly, even that habit might begin to loosen as the journey pulled farther away from everything ordinary human experience is built around. That is when distance starts to feel heavy, not because space becomes crowded with obstacles, but because it becomes so spare that the mind has very little to hold on to, except time itself. Days pass, then years. Familiar worlds fall farther behind. The map does not disappear, but it stretches until its inner parts begin to feel less like surroundings and more like the opening chapter of a much longer story. And that may be the deepest emotional truth of such a journey. The farther outward we go, the less the solar system feels like a set of destinations, and the more it feels like a thinning connection to the place we began. The planets remain where they are. The sun remains at the center, but the traveler's relationship to them changes. What once felt immediate becomes remote. What once felt like place becomes history. That is why the outward journey carries such weight even before any final edge is reached. It slowly teaches a new sense of scale. It teaches patience. It teaches how long it takes for familiarity to fade when the space between things is this large. And once we imagine the journey in that more human way, another question becomes harder to avoid. A machine can endure a slow crossing through silence without caring what it feels like. But could a human being ever truly make sense of a journey that unfolds on these terms? That question changes the moment we place a person inside the journey. A robotic spacecraft can keep going without boredom, loneliness, fear, or doubt. It does not mind that the trip is long. It does not care that one milestone may take years to reach, and another may take decades. It does not need comfort, sleep, fresh food, or a reason strong enough to carry it emotionally through the silence. A machine can simply continue. A human being cannot do that so easily. The moment we imagine a person making the same outward crossing, time stops being only a technical issue and starts becoming a human one. A journey that sounds manageable for a probe can become deeply strange when measured against a human life. Even if a person could survive the launch, survive the radiation, survive the isolation, and survive the systems needed to stay alive, there would still be another question waiting underneath all of that. What would it mean to spend so much of a life simply going outward? That is where the scale of the solar system begins to feel different again. For a machine, decades are only elapsed time. For a person, decades are a life-changing shape. Childhood becomes adulthood. Adulthood becomes old age. Families change. Languages shift. The world at home does not stay still while the traveler moves through darkness. Even if the mission succeeds perfectly, time itself becomes one of the heaviest parts of the journey. And that is only one part of the problem. A human mission would also have to carry its own world with it. Air, water, food, waste systems, shielding, medical care, mental stability, and some reason to keep going when the scenery changes very little and the destination remains painfully far away. A person does not just travel through space. A person brings biological needs, emotional needs, and limits of attention. The mission becomes less like sending an instrument outward and more like trying to preserve a tiny island of life inside an immense emptiness. That changes the meaning of distance. With a robot, the question is mostly whether the craft can endure long enough and whether its systems can still function. With a person, the question becomes larger. Can a human body endure the environment? Can a human mind endure the time? Can a mission remain meaningful when the crossing itself may take such a large part of a lifetime? That last point matters more than it first seems. Machines do not need purpose. We give them purpose. Humans need to feel the purpose from the inside. That means a human journey to the edge of the sun's world would never be only a transportation problem. It would also be a problem of meaning. Why are we going? What counts as success? Is the goal to arrive, to study, to prove something, to survive, or simply to cross a threshold? A robotic mission can live with a narrow answer. A human mission usually cannot. The farther outward we imagine the journey, the stranger that becomes. A human trip to Mars is already difficult to picture in full. A human trip beyond the outer planets begins to feel much heavier. A human trip toward the heliopause or beyond it starts to move into a category where engineering, biology, and psychology all begin to pull against one another. The destination may still be real, but the human relationship to it becomes harder to justify in the ordinary terms we use for exploration. And yet there is something revealing in that difficulty. It shows that the outward scale of the solar system does more than challenge our machines. It challenges the shape of human life itself. It asks whether our current bodies, lifespans, and emotional rhythms are built for journeys of this kind. It asks whether some distances belong more naturally to instruments than to people, at least for now. That does not make the human version meaningless. In some ways, it makes it more profound. It reminds us that when we imagine sending a person outward through these vast layers of space, we are not only imagining a mission, we are imagining a different relationship between life and distance. We are imagining what it would take for a human being to remain whole while moving through time on the scale of the outer solar system. So once a person enters the picture, the journey becomes stranger and more serious. The question is no longer only how far or how long. It becomes how a life fits inside that length of time at all. And once we begin to feel those limits clearly, one more possibility starts to matter. If the problem is partly that human beings are too slow for distances this large, then could future propulsion change the scale enough to make the journey feel different? That possibility is hard to resist. Once we feel how heavy the journey becomes for a human being, the mind naturally starts looking for better engines, better methods, better ways of pushing outward. It is easy to imagine that the real problem is simply that our technology arrived too early. Give us stronger propulsion, more advanced materials, more efficient power, and perhaps the outer solar system would stop feeling so severe. Perhaps the long crossing would begin to shrink into something more manageable. There is truth in that hope. Future propulsion could absolutely change the numbers. More powerful systems could cut down travel time. Nuclear propulsion, advanced ion drives, fusion concepts, light sails, or other ideas not yet fully realized could move spacecraft outward faster than the missions we have relied on so far. A journey measured in many decades might become shorter. A route that now feels almost unreasonable for people might begin to feel closer to serious planning. That matters. It is not a small change. But even hopeful futures run into the same larger fact. The solar system is huge in a way that resists easy conquest. Better propulsion can reduce the time. It cannot make the map itself small. That is the deeper point. We often picture future technology as something that completely transforms a hard problem. And sometimes it does. A machine that once took hours can be replaced by one that works in seconds. A message that once took months can arrive instantly. We become used to progress behaving like magic because, in daily life, it often feels that way. Space keeps humbling that instinct. A faster engine would help. A much faster engine would help more. But when the distances are measured across the sun's immense outer domain, improvement does not erase scale. It only changes how quickly we move through it. The emptiness remains. The long outward layers remain. The psychological weight of the journey remains, even if its length becomes less punishing. A useful way to think about it is this. Imagine making the road twice as fast to cross. That matters. Now imagine the road is so long that even after doubling your speed, it still takes years to reach the first deeply meaningful threshold. In that case, the technology has improved, but the road has not stopped being immense. That is what the solar system does to our ambitions. It accepts improvement without surrendering its grandeur. So yes, future propulsion could make leaving the sun's world more realistic. It could make robotic missions far more efficient. It could make some human missions less impossible than they seem today. It could turn certain thresholds from lifetime-scale dreams into missions that a person might actually imagine joining. That is real progress, and it should not be dismissed. But there is a difference between making a journey more possible and making it feel easy. Easy suggests that the challenge has been tamed. Easy suggests that the outer solar system has become something like an upgraded version of air travel, or even a long sea voyage. Nothing in the scale we have explored suggests that. Even in a better future, the Sun's domain would remain a vast layered territory with long crossings between major changes in environment. The crossing may become more achievable. It does not become ordinary. That is why future propulsion fits into this story in such an interesting way. It gives hope without removing awe. It lets us imagine a more capable civilization while preserving the greatness of the thing being crossed. The solar system does not lose its size just because our machines improve. In a strange way, improvement may even sharpen our respect for it. The more we learn how hard it is to move outward efficiently, the more clearly we see what kind of place we are living inside. And that shift matters for more than engineering. Because once the crossing begins to feel even slightly more realistic, the solar system starts changing in the human imagination. It stops feeling only like a backdrop to astronomy and starts feeling more like a real territory. A place with inner regions, outer regions, thresholds, distances, and meaningful crossings. A place that may one day be traveled through more deliberately, even if never casually. So future propulsion does not end the mystery. It gives the mystery a new shape. It tells us that the numbers can change while the deeper feeling remains. We may become faster. We may become bolder. We may learn how to send machines and even people much farther outward than we can now. And the solar system may still remain large enough to remind us that progress is not the same as mastery. That realization opens the story outward again. Because if crossing the solar system becomes more realistic over time, then our relationship with the solar system itself begins to change. It starts to feel less like a diagram we study and more like a place we may one day truly inhabit. That is one of the quiet changes this kind of journey creates. At first, the solar system often lives in the mind as a diagram. The sun in the middle, rings or ovals around it, planets placed at intervals, perhaps a few labels, perhaps a dark background with stars. It is something we learn, something we point at, something we reduce into a clean image that fits on a page or screen. That kind of map is useful. It teaches order. It shows relationships. It helps us understand where Earth sits among the other worlds. But once we begin to imagine actually crossing it, the diagram starts to break apart. It stops feeling like a picture and starts feeling like territory. That is a deeper shift than it may first seem. A diagram can be understood all at once. A territory cannot. A diagram gives you the whole at a glance. A territory has to be lived through, crossed slowly, measured in time as much as in distance. It has near regions and remote ones. It has familiar centers and fading outskirts. It has places that feel active and places that feel silent. Once the solar system becomes that kind of place in the imagination, our relationship to it changes. The planets change first. They stop being only facts in order from the sun and start feeling like real regions within a much wider domain. Earth becomes the inhabited inner point of origin. Mars becomes the nearby frontier. Jupiter and Saturn become massive middle distances, giant markers in the wider structure. Uranus and Neptune stop feeling like names from a textbook and begin to feel like remote outer provinces. Even the dark regions beyond them take on more shape. The Kuiper belt becomes less like a label and more like a sparse outer field. The heliopause becomes less like a scientific term and more like a boundary someone might one day speak about as a true crossing. That is what territory does. It gives emotional weight to geography. And once the solar system gains that weight, it starts to feel more inhabited, even in the places where almost nothing lives. Not inhabited in the simple sense of cities and people, but inhabited by meaning, by roots, by possibilities, by remembered missions and imagined ones. A place becomes real when we can picture moving through it, waiting through it, planning across it. That is when space stops being only astronomical and becomes historical too. Human beings have done this before, in smaller ways. A coastline is just a shape until it becomes a route. A desert is just a region until it becomes a crossing. An ocean is just a large body of water until ships move through it often enough that its distances enter culture and memory. Something similar happens here, even if much more slowly, and on a scale almost beyond comprehension. The more seriously we think about moving through the solar system, the more it stops feeling abstract. It starts to feel like the first environment beyond Earth that civilization may someday understand in the language of movement, rather than only observation. That change is important because it also changes what far away means. When the solar system is only a diagram, everything beyond Earth can blur together into one idea called space. But when it becomes territory, the distances separate. Mars is one kind of away, Jupiter is another, Neptune is another still. The heliopause becomes its own kind of remoteness. Interstellar space becomes something farther and quieter, beyond a threshold that has meaning, because the territory behind it has already become real. This makes the solar system feel larger, but it also makes it feel more intimate in a strange way. The map becomes richer, the places acquire texture. The whole structure begins to feel less like a science lesson and more like the early outer landscape of a species that has only just begun to understand where it lives. The sun is no longer only a star at the center of a model. It becomes the center of a vast region with layers, zones, thresholds, and long paths extending outward from one small inhabited world. And once we begin to think that way, the outward edge of the solar system changes as well. It no longer feels like the end of a diagram. It starts to feel like the border of a first territory. That thought carries a quiet weight. Because if the solar system is a territory, then crossing its edge begins to feel less like solving a question on paper and more like stepping beyond the first home range of our civilization. It becomes a threshold in a much larger human story, and that naturally turns the mind toward what lies beyond. If the solar system is the first great territory around us, then what is interstellar space supposed to feel like once we reach it? That is where the journey becomes stranger again. It is easy to imagine interstellar space as a kind of arrival. The phrase itself sounds final. It suggests that once a spacecraft crosses the outer threshold of the sun's local bubble, it has at last reached some new realm, some new destination beyond the solar system. And in one sense, that is true. A real boundary has been crossed. A meaningful transition has taken place. The environment around the craft has changed. The sun's outward breath no longer shapes the local space in the same direct way. But emotionally, something else happens at that same moment. The edge does not open into a new world. It opens into a greater emptiness. That is why leaving the solar system is less like arriving in a place and more like entering a wilderness. On Earth, crossing a border usually means entering another region with its own landmarks, its own structure, its own signs of life or activity. Even a remote place still gives the mind something to hold on to. A new coastline, a new mountain range, a new city, a new sky over the same ground. Interstellar space offers almost none of that. It is not crowded with nearby stars waiting just beyond the heliopause. It is not a busy sea of destinations. It is mostly distance, mostly darkness, mostly separation. That is one of the hardest parts of the scale to truly feel. The sun's bubble may be vast, but the space between stars is vaster still. Crossing into interstellar space does not mean the next star is suddenly close. It means the spacecraft has left one domain and entered the wide interval between domains. It has reached the long silence between stars. That is a genuine beginning, but it is the beginning of a much larger loneliness. In that sense, interstellar space changes the whole meaning of the outward journey. Up to this point, much of the travel could still be understood as movement through the sun's territory. However faint the outer layers became, they still belonged in some way to the same general home system. The sun was still the organizing center, its planets, its outer regions, its bubble of solar wind. All of it formed one continuous structure. Once that boundary is crossed, the structure loosens. The spacecraft is no longer moving deeper into the solar system. It is moving between stars. That may sound like the grand conclusion. In truth, it is a much quieter beginning, because what lies ahead is not immediate discovery in the way people often imagine discovery. There is no nearby planet waiting just over the line. No bright marker that says the next chapter has fully begun. There is only the realization that the solar system itself, which once seemed so unimaginably large, is also only one star's local region inside a galaxy filled with countless others. That realization carries a peculiar kind of beauty. It shrinks the solar system and enlarges it at the same time. It shrinks it because interstellar space reveals that the sun's whole domain is only one island in a much wider cosmic sea. But it also enlarges it because it shows how much it took to leave even that one island behind. The crossing means more once we understand what lies beyond it. The threshold feels more real because it does not end the mystery. It deepens it. That is why interstellar space should not be thought of as the finish line of the journey. It is the point where one kind of belonging ends and another kind of uncertainty begins. A spacecraft crossing that threshold has done something extraordinary, but it has also stepped into a region that offers very little comfort to the human instinct for landmarks. The old map is behind it. The new map is almost blank. And perhaps that is exactly what gives the moment its power. The edge of the solar system matters because it feels like the border of home. But the wilderness beyond matters because it reminds us that home itself exists inside a much larger emptiness. The crossing is meaningful precisely because it does not lead to easy familiarity. It leads to greater scale. So the end of the outward journey turns out to be a beginning after all. It is the beginning of the space between stars, the beginning of a new kind of remoteness, the beginning of a question even older and larger than the one we started with. Because once we picture that wilderness clearly, another thought begins to rise almost on its own. If the space beyond the solar system is so empty, so quiet, and so vast, why does it pull on the human mind so strongly in the first place? That pull may come from the very fact that the journey is too large for us. Human beings are drawn to things that exceed them, not always because they expect to conquer them, and not always because they think the answer will be useful in an immediate way. Sometimes the attraction is almost the opposite. A question becomes powerful because it is larger than one life, larger than one mission, larger than the normal scale of daily human plans. It gives the mind something immense to stand beside. That is part of what makes a journey outward through the solar system so compelling. Most of us will never travel that far. Most of us will never see the outer planets with our own eyes, never cross the heliopause, never enter the long dark between stars. And yet the question still matters. In some ways, it matters more because of that distance. It becomes a way of measuring the reach of human curiosity against the size of the universe around us. That is a very old habit of mind. People have always asked questions that stretch beyond what they could personally complete. How large is the world? What lies beyond the horizon? What is across the ocean? What happens after the mountain range, after the desert, after the sky itself? Even when the answers were incomplete, the act of asking still changed something. It widened the imagination. It gave people a way to place themselves inside a larger reality. The outward journey from the sun does something similar. It begins with engineering, speed, distance, and thresholds. Those are real parts of the story. But underneath them is a quieter human need. We want to know how far things go. We want to know where our home ends. We want to know what it would mean to move beyond the region that formed us. Even if the crossing takes longer than one person can comfortably hold in view, the question still feels alive because it tells us something about the kind of creatures we are. We are local creatures with non-local minds. We live on one planet, inside one atmosphere, under one sky. Our lives are short. Our bodies are fragile. Our attention is often pulled toward very small and immediate things. And still, the human mind keeps leaning outward. It keeps asking about distances it cannot walk, timescales it cannot live through, and journeys it cannot personally finish. That may seem impractical, but it is also one of the clearest signs of intelligence and culture. A species becomes more than local when it begins caring deeply about scales it cannot physically inhabit yet. It becomes more than present bound when it asks questions whose full answer may belong to future generations. That is why the longest version of the outward journey carries such meaning. If leaving the planets takes years, that is one scale of patience. If reaching the heliopause takes decades, that is another. If fully escaping the sun's long gravitational family stretches into something even greater, then the question begins to live partly outside individual life and partly inside civilization itself. At that point, the journey is no longer important, only because of where it goes. It becomes important because of what it asks from the imagination. It asks us to think in layers, in lifetimes, in generations, in the slow outward movement of knowledge. It asks us to treat discovery as something that may begin with one group of people and only fully ripen under another. There is something deeply human in that. A tree may be planted by one person and enjoyed by another. A cathedral may take longer to build than one generation can oversee. A scientific instrument may be launched by engineers who know they will never live to see the farthest chapter of its story. The outward movement of a spacecraft toward interstellar space belongs to that same pattern. It is a work of patience more than possession. And maybe that is why it stays with us. The question matters because it lets us feel, all at once, how small we are and how unusual we are. Small because the distances are overwhelming. Unusual because despite those distances, we still ask, we still calculate, we still imagine. We still send instruments into the dark and wait for the answer to arrive, even if the waiting itself becomes part of the answer. So the fascination is not really a mystery after all. We care about journeys beyond our own lifetimes because they allow us to think beyond our own lifetimes. They let us participate in something larger than a single person's story. And once the question becomes that kind of mirror, it points back toward the present in a new way. Because if this outward journey says something about the kind of species we are, then what does it say that we are asking it now, in our own era, with the tools and limits we have today? That is what gives this journey its particular kind of weight. It would be easy to place a question like this in some distant century and let it drift into science fiction. We could imagine a far future with engines far beyond our own, with ships designed for deep interstellar travel, with technologies so advanced that the scale of the solar system begins to feel less intimidating than it does today. That version has its own appeal. It lets the mind roam freely. It turns the problem into something grand and speculative. But asking the question in modern day does something more intimate. It places the journey inside our own reach, even if only partly. It forces the imagination to work with the tools, limits, and knowledge of the civilization that exists right now. It makes the answer feel less like fantasy and more like a statement about who we are at this moment in history. That matters because the difference between now and some imagined future is not just technological, it is emotional. If the question belonged only to a far-off age, then it would say very little about us. It would become a story about people who do not exist yet, using machines we do not have, solving problems we can only guess at. Interesting, perhaps, but distant. Safe. Easy to admire from afar. In modern day, the question becomes more revealing. It asks what our civilization could really do, what our current technology can really reach, and how large the solar system remains when measured against our actual ability. That is why the answer feels stronger when it stays grounded in the present. With modern-day spacecraft, the outer planets still take years to reach. The heliopause still belongs to the scale of decades. The wider gravitational edge of the Sun's domain stretches farther still. Those are not guesses about a remote future. They are reflections of our real condition. They tell us where we stand. They show the current size of the gap between human ambition and cosmic distance. And that gives the whole thought experiment a more honest kind of power. It stops being a question about what some hypothetical civilization might someday do and becomes a question about what our own civilization already means. We are a species that can leave Earth. We can reach other planets. We can send machines past the outer worlds and into interstellar space. That is already extraordinary. At the same time, we are still early enough that the outer edge of the Sun's local bubble remains a journey of long patience rather than quick mastery. That combination is what makes the present so interesting. We are advanced enough to begin. We are still young enough to be humbled. Those two truths together create a very particular atmosphere around the question. It becomes a portrait of a civilization standing near the edge of its first great outward era. We are no longer trapped entirely on one world in our imagination. We have learned how to move through the solar system in real and lasting ways. And yet, the distances still feel immense enough to remind us that our reach, though growing, is still narrow compared with the territory around us. That is why grounding the journey in modern day makes it feel more meaningful than simply asking it in the abstract. It ties the scale of the answer to the stage of development we are actually living through. It tells us that the solar system is not only vast in some timeless sense, it is vast relative to us right now, with all our current skill, all our current power, and all our current limits. In that way, the question becomes a mirror of the present. It shows us how far we have already come from the era when the planets were only lights in the sky. It also shows us how far we still are from treating the outer solar system as something easy to cross. It captures a civilization in transition, no longer purely local, not yet deeply interstellar, standing somewhere in between. That is a meaningful place to stand. It means the question is not just about a spacecraft. It is about timing in a broader sense. It is about asking what it means to live in the age where outward escape from Earth is real. Outward exploration of the planets is real, and the threshold into interstellar space has already been touched by our machines, yet still remains large enough to feel almost mythic. And once the question is grounded that way, another thought begins to follow naturally. If a mission left in our own era, with our own tools and our own understanding, how would people in the future look back on that moment? Would it seem small and primitive, or would it feel like one of the first serious steps beyond humanity's original neighborhood? That question begins to change once we stop looking at the journey from our own moment and try to see it from farther ahead. History has a way of making early steps look larger than they seemed at the time. The people living through them often experience them as uncertain, partial, and limited. The machinery is imperfect. The results arrive slowly. The meaning is still unclear. From inside the moment, it can feel as though something important may be happening, but it is difficult to know how important. Then time passes, and the same event begins to look different. What once seemed modest starts to look like the beginning of an era. The outward journey from the solar system may one day be remembered that way. From our point of view now, a mission leaving Earth and heading toward the outer thresholds of the sun's domain can still feel narrow and technical. It may seem like a probe, a project, a difficult but distant piece of engineering. It may be discussed in terms of launch windows, instruments, trajectories, power systems, and years of travel. Those things are real. They matter. But future generations may not focus on them first. They may focus on what the mission represented. They may see it as one of the first times human civilization seriously treated the edge of the solar system as something meant to be approached, crossed, and understood through direct passage rather than distant imagination alone. They may look back and see a culture that was still early in its outward development, still confined in many ways to one inhabited world, and yet already sending its attention and its tools toward the boundary of its first great home region. That would make even a modest departure feel symbolic, because symbols do not need to be fast. They do not need to be elegant. They do not even need to complete the whole story on their own. Sometimes their importance comes from the fact that they begin a pattern. They show what a civilization has started to think is possible. They reveal the direction of its ambition. They mark the moment when a question changes from fantasy to practice. That may be how future people view our first serious outward departures. They may understand all the limitations very well. They may know that the probes were slow by later standards. They may know that the missions took decades to reach the first strong threshold. They may even smile at how primitive some of the technology seems from their perspective. But that would not erase the importance of the step itself. In some ways, it might increase it, because the more limited the tools were, the more remarkable it becomes that the attempt was made at all. There is something deeply recognizable in that pattern across history. The first ships that crossed unknown oceans were fragile compared with later ones. The first aircraft were simple compared with what came after. The first machines sent beyond Earth were tiny compared with the vastness around them. And still, those beginnings matter. They matter because they changed the shape of what came next. They expanded the horizon of the possible. They created memory. They gave later generations a point in time they could look back to and say, that was when the boundary started to move. The solar system has its own version of that waiting to be written. A mission that leaves in our era might not be remembered mainly as a machine. It might be remembered as a gesture made by a young civilization. A gesture outward, a declaration, quiet but real, that the region around the sun was no longer just a place to observe from inside, but a territory to cross in stages. Even if the mission itself remained small, the meaning attached to it could grow much larger with time. That is what hindsight often does. It gathers scattered efforts into a story, and once the story begins, the engineering details do not disappear. They simply take their place inside something broader. A launch becomes more than a launch. A crossing becomes more than a measurement. A spacecraft becomes more than a tool. Together, they become evidence that a species had begun to lean beyond the neighborhood that formed it. That thought carries us very close to the quiet center of the whole journey. Because once we imagine the future looking back at our first outward steps this way, another question begins to rise beneath all the distances, all the thresholds, and all the years of travel. When we say we want to leave the solar system, what are we really hoping to leave behind? And what is it that we hope to reach? That question may matter because it is never only about the edge. On the surface, it sounds like a problem of distance, a point in space, a number of years, a spacecraft moving outward through darkness until, at last, some threshold is crossed and the answer is complete. That is how the journey begins in the mind. We want to know how long it takes. We want to know where the solar system ends. We want to know what modern human technology can really do against a space so large that even the outer planets are only early landmarks. But after following the question all the way outward, something quieter begins to appear underneath it. The journey does not only tell us where the edge is, it tells us what kind of beings we are for asking about it in the first place. That may be the deepest meaning hidden inside the whole thought. The solar system is vast beyond ordinary instinct. Its planets are scattered across distances that already strain the imagination. Its outer layers fade into regions most people never picture at all. Its first strong threshold, the heliopause, takes decades to reach with modern-day technology. Its deeper gravitational reach stretches farther still. The farther outward we looked, the larger home became. And yet, even after feeling all of that scale, the human mind does something remarkable. It keeps going. It keeps tracing the path beyond the planets, beyond the icy outskirts, beyond the sun's great bubble, into the wilderness between stars. It keeps asking how long the journey would take, what the milestones would mean, how future people might remember the attempt, what it would feel like to watch home thin out behind us. The body remains on Earth. The imagination does not. That is what makes the edge of the solar system feel like a mirror. It reflects the size of our home, yes, but it also reflects the size of our curiosity. A species living on one small world, inside one atmosphere, under one ordinary sky, has learned to think across distances it cannot yet cross with ease. It has learned to build machines that continue outward long after their makers grow old. It has learned to care about thresholds that sit far beyond any practical daily need. That is a strange and beautiful thing. The answer, in the end, is not one number. If we mean leaving the planetary region, the timescale is one thing. If we mean moving beyond the Kuiper belt, it becomes larger. If we mean crossing the heliopause, the first threshold that truly feels like outside, then with modern-day spacecraft we are speaking of decades. If we mean the Sun's farthest gravitational family, the answer stretches into something larger still. All of those answers matter. Together, they reveal the layered size of the place we live in. But the more lasting part of the question may be what it does to our sense of ourselves. It reminds us that home is bigger than we casually imagine. It reminds us that leaving home, even in the first strong sense, is not a quick act of escape, but a long and patient crossing. It reminds us that the first territory around our star is already so wide that a human lifetime struggles to hold its full scale in view. And at the same time, it reminds us that the human mind is already reaching beyond it. That tension feels important. We are still early. We are still slow. We are still local in so many ways. And yet, we are no longer only local. We ask interstellar questions. We build outward-looking machines. We measure our own era against thresholds in deep space. We imagine how future generations will understand steps we are only beginning to take. We stand inside one small region of the galaxy and somehow manage to think beyond it. Perhaps that is the quiet answer resting beneath everything else. To ask how long it would take to leave the solar system is to discover that the destination matters, but the act of asking matters too. The question stretches the mind until it can feel both humility and wonder at the same time. Humility, because the sun's domain is so much larger than it first seemed. Wonder, because a creature from one small planet can still meaningfully ask about crossing it. So the edge of the solar system is not only a boundary in space, it is also a line that shows us something about ourselves. It shows us that we are born in one place and think past it. It shows us that we live short lives and ask long questions. It shows us that even before we fully leave home, part of us already has. And maybe that is enough, for now, to make the outward darkness feel a little less empty, and the place we began feel larger, stranger, and more beautiful than it did before.